Hi, hello, who are you? My name's Anna Ten Bensel, and welcome back to my channel. I thought 31 was going to be easy. It is, in fact, medium, but we are going to try to do it anyway. So, this is a LeetCode problem number 31, next permutation. I will be doing the solution today in Python. So, let's go over this question together. A permutation of an array of integers is an arrangement of its members into a sequence or linear order. So, for example, arrange equals 1, 2, 3. The following are permutations of that: 1, 2, 3, 1, 3, 2, 2, 3, 1, etc. The next permutation of an array of integers is the next logicographical larger permutation of its integer. More formally, it's a permutation of the array if all the permutations of the array are sorted in one container according to their lexicographical order. Then the next permutation of the array is a permutation that follows it in the sorted container. If such arrangement is not possible, the array must be arranged as the lowest possible order, i.e., sorted in ascending order. And they give you some examples here, but given an array of integers, nums, find the next permutation of nums. This replacement must be in place and use only consistent extra memory. So then these are other examples, and these are the constraints. And I did read this twice before, and I'm sorry that I am terrible at pronouncing this. It's a lot for my mouth to handle. No jokes, please. So I think, and this might not be the most popular opinion, but I do think I want to put a binary search in here, just kind of right off the rip. But I think how I want this to go is start from one side of the array and find that first element. And then if we find the element, then and it's greater than the nums here, then we just swap it. And then if there's no element, that means that the array would already be the largest permutation. That's the logic I think I want to start with, but I don't know if that's exactly what I want to do entirely, because I do think for this a binary search function would be good. So I guess I'm going to start with initializing n as the length of nums, because we know that exists. And then we want to do this with I too. So I think what I want to see in this is while I is greater than or equal to 0. Yeah, I'm going to say while I is greater than or equal to 0. I guess, or nums I is greater than or equal to nums I plus 1. Yeah. Oops. Nums I plus 1. Then that'll just be I minus or equal to 1. So here I'm going to start my binary search. So if it is greater than or equal to 0, then let's do left, right, I plus 1 and minus 1. So that while left is less than or equal to right, then less than or equal to right, then mid is going to be left plus right minus, why did I do that period? Right minus left and 2. So that way, if nums mid is then less than or greater than nums I, then we decrement the mid by 1. Else we'll use the left, have left increment the mid by 1. So less than or equal to nums I. And I think I said right first. So then we say right mid minus 1. Else left equals mid plus 1. Meaning nums I, that's nums 1. Nums I, nums left minus 1 is then equal to nums left minus 1 to nums I. And then I want to reverse the remaining part to get the permutation from this binary search. Basically, this binary search is finding the smallest element greater than nums I. If I didn't already explain that, I'm sorry. My brain, after that last problem, is she's a little rough. Now I want to reverse that remaining part to get that next permutation. So what I'm going to be doing with that is I'm going to say left, right equals I. Train of thought. And then n minus 1. So while the left is less than right, we have a nums left, nums right equal to nums right, nums left. So that will reverse that over. And then what we're going to do is say left is plus equal to 1, and then right is minus to 1. And I'm thinking that should work. So we initialized, do not return anything. So I'm not going to return anything. Let's read through this problem one more time just to make sure I'm not missing anything. So permutation of the array of integers is an arrangement of its members into a sequence or linear order. The next permutation of an array of integers is okay. Okay, so we got that first index, right, where we want, which is I, right, where nums I is smaller than the next element, which would be that nums I plus 1. And that's this area here. So then we have if I is greater than or equal to 0, that means like there's another permutation that exists. We need to swap some stuff in nums 1 with the smallest element greater than that comes after it. Does that make sense? So that binary search will then perform that search between indices, which is that remaining part of that array. And then once the correct index is found and stored in left minus 1, then we swap nums I with nums left minus 1 to get the next permutation. And then we complete that permutation by reversing it, which basically just ensures that the remaining part of that array is in ascending order. And that should work. And I'm saying should, but we don't know. I almost hit submit. Whew. But we're going to check. Invalid syntax. Oh my gosh. Please find all my mistakes. Please do this. Okay. I'm not as surprised by that. I would actually be more surprised if it got accepted. And it did. And it did. And it got over 50 on each. What a great day, you guys. And that only took about 10 minutes, but my brain needs a rest. I need to go for a walk. And then after the walk, I'll probably come back and do this stuff. But 92% beats 92% of users in runtime. That's pretty good. Memory 56. I'll take it. I will take it. I'll take it. Pretty good. Pretty good. I'm not complaining here. I think this logically makes sense. And I'm sorry if I didn't explain it that well. I can definitely explain it in just like an explainer video. But after that last problem here, it took me like 40 minutes and all of my brain power. My brain was just having a hard time coming up with the words while I was trying to think of it and write it out. So, yeah, that's all I got for you guys. I'm going to leave this code in the video description and the GitHub repo. Jeez Louise. Who let me do this today? I'm going to leave the GitHub repo with this code in the video description down below. Feel free to fork and clone, make it better, make it worse, try something new, learn something, have fun. And I will see you guys in the next video. Thank you guys so much for watching and being patient with me here today.